Number one, the variables x and y satisfy the equation a to the power 2y equal e to the power 3x plus k, where a and k are constants. The graph of y against x is a straight line. Use logarithms to show that the gradient of the straight line is 3 over 2 ln a. We need to take the natural logarithm based on this information, the natural logarithm for both sides, whether the left-hand side and right-hand side. So this equation becomes ln a to the power 2y equal ln e to the power 3x plus k, like this. And based on the ln rule or logarithm rule, we can write y ln a equal 3x plus k ln e. Ln e equal 1, so this equation becomes 2y ln a equal 3x plus k. So continue, 2y equals 3x plus k over ln a, or y equal 3x plus k over 2 ln a. Or we can write I'm going to scroll down first. Or we can write y equal 3 over 2 ln a x plus k over 2 ln a. So the gradient is this one. This is the gradient. 3 over 2 ln a. Because this is the coefficients of x. This one. So the gradient for m equal 3 over 2 ln a. That's the gradient, b. Given that the straight line passes through the coordinate points 0.4 and 0.95 and 3.3, 3.80, find the values of a and k. Right. The line passes through these coordinate points, so it means the gradient, we can determine the new gradient, 3.80 minus 0.95 over 3.3 minus 0.4 becomes 2.85 over 2.9. It is 0.9827586. This is the gradient, or you can using 0.983. Right. Let's continue. Based on the previous information on part A, that the gradient also is 3 over 2 ln a. Okay. And the gradient on this part B, is 0.9827586. So it means 2 ln a equal 3 over 0.9827586. And ln a equals 3 over 1.9655172. That is ln a equal 3 divided by this number. The result is 1.5263,158. So it means a equal e to the power this number, 1.5263 on, and the result is 4.595 or 4.6. This is A. From part A, we have information that y ln A equal 3x plus k from part A. Now, substitute the coordinate point 0.4, 0.95. This coordinate point, this is x, this is y, and as well substitute the result of ln A equal this number, okay, 1.526 on, substitute into this equation. So it becomes 2 times 0.95. This is y, and ln A, this is number 1.526 on, equal 3 times this one, 0.4 plus k. And after that, multiply this, the multiplication of this number is 2.8997 equal 1.23 times 0.4 plus k. So we can find k equal 2.8997 minus 1.2 equal 1.69997, or round off becomes 1.7. So A equal 4.6 and K equal 1.7. Next question. Number 2. Solve the inequality modulus x minus 7 greater than 4x plus 3. When we were solving the inequalities involving modulus, we have to break it into two cases based on the definitions or the absolute value. I would like to start in case 1. In case 1, we assume that x minus 7 greater than 0. Okay, which means x greater than or equal 7. The implications of this inequality becomes this one. So the modulus x minus 7 equal x minus 7. And the inequality becomes x minus 7 greater than 4x plus 3. Okay. So we need to solve for x. Okay. X minus 4x greater than 3 plus 7. So it means minus 3x greater than 10. And x less than minus 10 over 3. But in this case, we already assume that x greater than or equal 7, not this one. So it means this solution, okay, this inequality, and then x, this one, x greater than or equal 7, have no overlap. So no solution for this case. Next, the second case, or case 2. The case 2, that x minus 7 less than 0. The case 1, x minus 7 greater than or equal to 0. Case 2, x minus 7 less than 0, which means, so the implications of this inequality, x less than 7. So the modulus x minus 7 is equal minus x minus 7, or minus x plus 7. Scroll down first. Right. So the inequality becomes minus x plus 7 greater than 4x plus 3. That means minus x minus 4x greater than 3 minus 7. So minus 5x greater than minus 4. So it means x less than 4/5. 4/5 becomes positive because negative divided by negative. So in this case, we require that x less than 7. If you compare with this result, that it is automatically satisfied. If it is satisfied, so the solution, we can state, so the solution is x less than 4/5. Number 3, the function f is defined by fx equal tangent squared 1/2 x for x interval 0 to pi. When the exact value of derivative fx with x 2/3 pi. Right. First, we have to differentiate fx. Okay. This because this is the function fx with respect to x, of course. So the differentiations of fx equal to tangent. We are going to using chain rule. I would like to writing 1/2 x becomes x half. Okay, the x tangent x half like this. So it becomes 2 tangent x half. Differential of tangent x half equals secant squared x half times 1/2. So the differential or the derivative of fx equal 1/2 times 2 equal 1. It is tangent x half times secant squared of x half. And after that, substitute this information, x equal to 3rd pi, into this derivative. So it becomes derivative x tangent 1/2 times 2/3 pi, and it becomes 1/2 times 2/3 is 1/2. Writing this 1/2 2 pi third, like this becomes tangent 1/3 pi third secant squared pi third. Okay, so after that, we are going to find tangent pi third. Tangent pi third is square root 3, and second pi third is 2. So second squared means 2 squared. So the result is 4 square root 3. Next question. Find the exact value of this integral, right? Fx plus sin x dx. Integral 0 to pi half. Fx is tangent squared x half plus sin x dx. So it becomes integral 0 to pi half tangent squared x half plus dx, because I would like to separate sin x dx. Now, I'm going to find one by one this integral first, after that this integral, and then we're going to calculate, we're going to compute the result of this integral and the result of integral next. For integral 0 to pi half of tangent squared x half dx. So it becomes integral 0 to pi half tangent square x, it equal second square x minus 1. So I would like to writing this integral becomes second square x half minus 1 dx. Now using substitution, the substitution u equal x half, so it means du equal 1 half dx, and then dx, it means dx equal 2 du. So we will using this substitution to find the solutions of this integral. All right, let's continue. So it becomes find the integral first of this expression, integral second squared x half dx is equal to based on this substitution, 2 second u du, so this squared, or it is the integral of this expression second squared u, it is 2 tangent u plus c. This is for the indefinite integral. So it means the integral 0 to pi half of this one, second squared x half minus 1 dx. This integral 0 to pi half, the integral is 2 tangent x half minus x, like this, based on this result for this one. Scroll down first. Right. Let's continue. So after that, substitute pi half and 0 into this expression. So it becomes, I'm going to put it here, becomes 2 tangent pi quarter minus pi half minus 2 tangent 0 minus 0. And This result is 2 times 1 minus this 1 by half, and this result is 0 minus 0, okay, plus 0, okay, minus 0 plus 0, so it becomes 2 minus by half. That's 4 first. Now, 4 integral 0 to pi half of sine x dx. The integral of sine x is minus cosine x. Substitute pi half and 0. Becomes minus cosine half minus minus plus cosine 0. So the result is this is 0 and this is 1. So it is 1. So let's recompute. So for the integral 0 to pi half of tangent square x half plus sine x dx is 2 minus pi half plus 1. It is 3 minus pi half. This is the solution. Next question. Number 4. The polynomial px is defined by px equal ax cubed minus ax squared minus 15x plus 18. Where a is a constant, it is given that x plus 2 is a factor of px. Find the value of a. All right. If x plus 2 is a factor of px, so it means p minus 2, the result is 0. If p minus 2, the result is 0, we can substitute minus 2 to here, into this x, so it becomes like this. P minus 2 equal a minus 2 cubed, a minus 2 squared, 15 minus 2 plus 18 equals 0 based on this information. Okay. Right, so let's calculate. Minus 8a minus 4a plus 30 plus 18 equals 0. So minus 12a plus 48 equals 0. And then minus 12a equal minus 48. So a equal minus 48 over minus 12 equal 4. So a equal 4. Let's continue. And let's factorize px completely. So if a equal 4, the function px becomes 4x cubed minus 4x squared minus 15x plus 18, which x plus 2, x plus 2 is a factor. Okay. I will be using the Horner method. Horner method like this. X plus 2 is the factor, so this is minus 2, and it is 4 minus 4 minus 15, 18. 4 minus 2 times 4 minus 8. This is minus 12. This is 24. This is 9. is minus 18. And the remainder is 0. So px equal x plus 2 times 4x squared minus 12x plus 9. So after that, I would like to factorize this. Okay, find two numbers if multiply 36 because 4 times 9, and if you adding it becomes minus 12. So x plus 2, I have factorized this to x minus 3 and to x minus 3. So px equal x plus 2 times 2x minus 3 squared. So this is the factorizations of px, the completely factorization. C. Solve the equation p cosecant squared theta equals 0 for theta greater than minus 90, less than 90. Right. So from part B, we have information that px equal x plus 2 times 2x minus 3 squared. Based on the questions, we set this question, okay, we set x plus 2 times 2x minus 3 squared equals 0. Okay, this is minus. So it means x equals minus 2 or x equal 3 half, like that. For cosecant squared theta equal minus 2, okay, because I'm going to set this that for px equal these expressions with assumption x equal cosecant squared theta. So if x equal minus 2, it means cosecant squared theta equal minus 2. So it becomes cosecant squared theta 1 over sine squared theta equal minus 2. So if you evaluate this equation, this result of 1 over sine squared theta is always positive. So we are going to ignore this this equation. Impossible if 1 over sine squared theta, the result is minus 2. So impossible because the result of 1 over sine squared theta always positive. Ignore this solution. Next, for cosecant squared theta equal 3 half. This is 1 over sine squared theta equal 3 half. So it means sine squared theta equal 2/3. So it is sine theta equals square root 2/3. Then theta equals sine arc sine or sine power minus 1 square root 2/3. It is 54.7. So theta equal 54.7. That's the next question. Number 5. It is given that integral a to a cube of 10 over 2x plus 1 dx equals 7, where a is a constant greater than 1. Show that a equals this cube root. Okay, so first we're going to evaluate this integral, this indefinite integral. So integral of 10 over 2x plus 1 dx. Let u equal 2x plus 1. So it means du equal to dx. And then dx, it means equal 1/2 du. So this integral becomes 10 over u, 10, because u to x plus 1 times 1/2 du, like this, or it becomes 10 divided by 2, 5, 1 over u du. It is 5 ln u plus c. So it becomes 5 ln 2x plus 1 plus c. So integral, now the definite integral of a to a cube of 10 over 2x plus 1 dx, sorry, I mean here, okay, dx is integral a to a cube. The integral of this expression is 5 ln 2x plus 1, and substitute a cube and a into this expression. I would like to scroll down first. Okay, so it's going to be 5 ln 2a cube plus 1 minus 5 ln 2a plus 1. Based on the ln rule, we can write in this 5 ln 2a cube plus 1 over 2a plus 1, like this. And if we look at the question, this statement that this integral equals 7. So I'm going to set this result equals 7, like this. Okay. So I'm going to move here, it means ln 2a cube plus 1 over 2a plus 1 equals 7 fifth, like this. And then we can write in 2a cube plus 1 over 2a plus 1 equal e to the power 7 fifth. And then scroll down first. And then 2a cube plus 1 equal e power 7 fifth times 2a plus 1, like this. And 2a cube equal e to the power 7 fifth times 2a plus 1 minus 1, like this. So now I'm going to divide by 2. If you divide by 2, it becomes 2 times, wait, I would like to divide 2e power 7 fifth plus e power 7 fifth divided by 2. divided by or times 1/2. So if times one half, it's gonna minus one. Sorry, minus one. We got minus one. It's minus one here. That's 1/2. So it becomes e power 7/5 a plus e power 7/5 minus 1 over 2, like this. Okay. So after that, here a cube equal this is factorized. I would like to factorize 1/2 e power 7/5 times 2a plus 1 minus 1/2. So this is the factorization of this form. So it means the result a equal cube root 1/2 e power 7/5 to a plus 1 minus 1/2. So this is a. Question B. Use an iterative formula based on the equation in part A to find the value of a correct three significant figures. Use an initial value of 2 and give the result of each iteration to 5 significant figures. From part A, we got that A equals cube root of 1/2 e power 7/5 to a plus 1 minus 1/2. So set up an iterative formula becomes a n plus 1 equal cube root of 1/2 e power 7/5 to a plus 1 minus 1/2. So I would like to change this e power 7/5 in decimal number. It is 4.0552. So it means an plus 1 cube, an plus 1 for cube root of 2 because 1/2 times this number, if this is times 1/2, equal 2.0276. So 2.0276 to an, okay, plus 1 minus 0.5 for the iterative formula. Now, when a0 equal 2, the calculation becomes the cube root of 2.0276. 2 times 2 plus 1 minus 0.5. The cube root of 9.638. It is 2.1177. Next, when a1 equal this number, 2.1177, the calculation of iterative cube root 2.0276 times 2 times 2.1177 plus 1 minus 0.5. And if you calculate, the result is the cube root of 10.116. And this is 2.1651. Now, when A2 equal 2.1651, the calculations of iterative, the cube root of 2.0276 times 2 times 2.1651 plus 1 minus 0.5, and the result is the cube root of 10.309. The result 2.1759. When A3 equal 2.1759, the iterative calculation becomes cube root of 2.0276. 2 times 2.1759 plus 1 minus 0.5, cube root of 10.350. It is 2.1778. Okay. Next, when A4 equal 2.1778. So the iterative calculation becomes 2.0276 times 2 times 2.1778 plus 1 minus 0.5. It is cube root, this one. It is the cube root of 10.259. And the result is 2.1781. Now, if you compare this result, A3 and A4 result, the difference is 0.0003, the difference. So we can state that the value of A is 2. I mean 2, 0 is 2.1781 or 2.18. This is the result. Number 6. A curve has parametric equation x equals 1, y equals 1. Find an expression for dy dx in terms of t. We're going to find dy dx. The first step, I will find a derivative of x and then derivative of y. After that, you're going to find derivative dy dx. Right. Y equals 1. So it means dy dx equal 3e power 3t. And x equal this one. So I would like to using substitution for x. Okay, especially for x, that u equal e power to t minus 2. So it means du equal 2 times e power to t, so and phi e power to t plus 1. So the phi 2 e power to t. So dx dt, dx dt based on the formula dphi du dt minus u dphi dt over phi squared. So phi is 1 e power to t plus 1 times du dt. This one 2 e power to t minus u e power to t minus 2 times 2 e power to t over phi squared e power to t plus 1 squared. That is. And after that, multiply. This one multiply becomes 2 e power 4t plus 2 e power 2t minus 1 to e power 4t minus 4 e power 2t. Divided e power 2t plus 1 squared. And it becomes, this is comes 0 because 2 e power 4t minus 2 e power 4t is going to be 2 plus 4 becomes 6. 6 e power 2t over e power 2t plus 1 squared. This is the x dt. Now let's define dy dx. Dy dx, it is dy dt times dt dx. So dy dt, sorry, this is not dx, this is dt, I mean. This is dy dt, sorry. This is dy dt. So dy dt based on this information is 3e power 3t times dt dx. This is dx dt, so the opposite of dx dt. So it is 6e power, sorry, denominator first. Okay. The opposite, it means e power 2t plus 1 squared over 6 e power 2t. So it means this is divided becomes 1/2 e power 3t divided by e power 2t becomes e power t. And then e power 2t plus 1 squared. So dy dx is what? This is the result. Let's continue to part B. When the exact gradient of the curve at the point where the curve crosses the y-axis. When a line crossing the y-axis, it means x equals 0. So crosses the y-axis, so the implications x equal 0. Now we are going to find where we are going to find t when x equal 0. And the equation x equal e power to t minus 2 over e power to t plus 1. This equation from the equations at part A. Now, it's going to be if x equals 0, if this x equals 0, this equation becomes e power to t minus 2 over e power to t plus 1 equals 0, like this. So it means the implication e power to t minus 2 equals 0 because this denominator times 0 equals 0. So e power to t equal 2. Then based on the based on the rule that we can writing this as 2t equal ln 2. So it means t, I'm going to write it here, t equal 1/2 ln 2. Right. Next. After that, we will find the gradient dy dx at this t, this t value. From the part A, we have information that dy dx equal 1/2 e power t times e power 2t plus 1 squared. Okay? Gradient you can find from the first derivative. So you're going to find gradient through this derivative. Now substitute this information, t equal 1/2 ln 2 into this derivative. So it becomes 1/2 e to the power 1/2 ln 2 times e to the power 2 times 1/2 is 1. So this is ln 2 plus 1 squared. I'm going to continue the calculation. 1/2 e power. I would like to set this expression becomes ln 2 power 1/2 like this. Continue with this one. And e power ln 2, I would like to convert becomes 2 because e power ln 2, it is, if e power ln a, it is actually equal a. Okay, if this is a power n, it is a power n, the result. Okay, so that's why ln e power ln 2 equal 2 plus 1 squared. So let's continue. So now this one, it becomes 1/2 because e power ln 2 power 1/2. Okay, it is 2 power 1/2 based on this rule, right? Times 3 squared. This. So if you continue the calculation, it becomes 1/2 square root 2 times 9. So it is 9/2 square root 2. So this is the gradient. Next question, number 7. Prove that cosine theta plus 30, cosine theta plus 60 equivalent with 1/4 square root 3 minus 1/2 sine to theta. All right. So cosine theta plus 30 cosine theta plus 60 is equal cosine based on trigonometrical identity. This part equal cosine theta cosine 30, I mean, sorry, cosine 30 minus sine theta sine 30 times cosine 60 cosine theta cosine 60, I mean, sine theta sine 60. Okay, so cosine theta cosine 30 is square root 3 half minus sine theta, and oh, this is sine 30 actually. Okay, so sine 30 is 1 half, and cosine theta cosine 60 is 1 half sine theta. Sine 60 is square root 3 half. Becomes, I would like to multiply this one. I need more space. Okay, it's okay. This one times one, this expression times this expression. So 1 half times square root 3 half becomes, wait, right here. I'm going to move here. Cool. If multiply becomes square root 3 quarter cosine square theta. So that multiply this one minus 3 quarter sine theta cosine theta. And then after that, this one and this one minus 1 half, 1 half. So 1 quarter sine theta cosine theta. And after that, this one and this one plus square root 3 quarter sine squared theta. So now this term and this term, okay, square root 3 quarter cosine squared theta plus sine squared theta minus, this is minus 3 quarter, this is minus 1 quarter, equal 1. 1 sine theta cosine theta. This is equal 1. Cosine squared theta plus sine squared theta equal 1. So it is square root 3 quarter minus sine theta cosine theta. According to trigonometrical identity, that sine theta, sine 2 theta, I mean, equal to sine theta cosine theta. So 1 half of sine 2 theta equals sine theta cosine theta. So it means sine theta cosine theta equal 1 half sine 2 theta. So this term I would like to writing 1 half sine 2 theta. So it becomes square root 3 quarter minus 1 half sine 2 theta. Next question. B. Solve the equations 5 cosine 2 alpha plus 30 cosine 2 alpha plus 60 equal 1. Right. From part A, we have the information that cosine theta plus 30 cosine theta plus 60, the result is square root 3 quarter minus 1 half sine 2 theta. It is. So I would like to change this theta, this theta, this theta becomes alpha, becomes 2 alpha. So it becomes, and also I will put 5 in front of this expression, becomes 5 cosine 2 alpha plus 30 cosine 2 alpha plus 60 equal square root 3 quarter minus 1 half sine 2 times 2 alpha, 4 alpha, like this. Okay. And based on this information, it equal 1. Now I will concern into this part. So square root 3 quarter minus 1 half sine 4 alpha equal 1. Or 1 half sine alpha, sine 4 alpha equals square root 3 quarter minus 1. Wait, there is 5 here actually. I forgot. This is actually 5 here. 5 here. Yeah. So it becomes 5 here. Yeah. Square root 3 quarter minus 1/5. Colon first. So it means here, actually here 5. I should be writing 5 here. Okay. Based on this information, this equal 1. So let's continue. So it becomes sine 4 alpha equal, this is 1 half, so it means 2 times square root 3 quarter minus 1/5, like this. So sine 4 alpha equal 2 times, this fraction becomes square root 3 half minus 2/5. And then it means 4 alpha equal arcsine or sine power minus 1 of square root 3 half minus 2/5. And this is 27.8. So alpha equal 27.8 over 4. And it is 6.95. Sign value is positive. Recall that the sign value positive also occurs on the second quadrant. Okay, the second quadrant, sign positive on the second quadrant, so we can determine for alpha also on the second quadrant. 80 minus 37.8. It is 152.2, right? So alpha equal 152.2 over 4. And alpha equal 28.05 is 28.1. So this is alpha. So there are two value of alpha, this one, and this one. So we can state that alpha equals 6.95 and also 38.1.